Hi everyone, this is Denise, and today I'm going to be performing our interactive lab for the magnetic field interactive lab. I just want to give a brief overview about some important aspects of this lab, just so that we can get familiar. So, material can react quite differently to the presence of an external magnetic field, which we'll be practicing today. Most fall into three categories. And these three categories consist of paramagnetic, diamagnetic, and ferromagnetic. Today we'll be focusing on the ferromagnetic properties. So ferromagnetic properties are used because of their large magnetic permeability compared to the other classifications I just mentioned for the magnets. So in this lab, I'll be using some ink toner that I already prepared in this lovely cup. And then I'll be using the rare earth magnets. So rare earth magnets right here. These are actually pretty strong. I tested them out in my fridge earlier, and it from a pretty far distance, it already grabbed some pretty good magnetism to the fridge. And then along with some vegetable oil, and it is 100% per the instructions. I am also using the cup along with the pipette right here. And the pipette I just had from my other chemistry courses as well. And then per the instructions, I went ahead and I added 2 tablespoons of the vegetable oil into this just to try to expedite the lab. So in this lab, like I said, I was using the 3 things, which is the toner, the vegetable oil, and the earth rare magnets. In this case, the rare earth magnet has a strong magnetic field strength, and the magnetic liquid, which is this, is a mixture of vegetable oil and laser jet ink toner. Okay. So what's supposed to take place right now is I went ahead and I stirred everything in just to give it a good they said not to do it too thin because then it could hinder the reaction that we want to get. So let's go ahead and see what happens. What's supposed to happen is it's supposed to drag up on the cup. Okay, right here. Perfect. Oh yeah, it is dragging. Can you see it? It's going upwards. Oh, this is kind of cool actually. Okay, cool. So that one worked. And that was part of the actual presentation we just did. And then let's go ahead and see if it works out the way that we need it to real quick. So let me just go ahead and prep my little cutting board because I don't have a table to do it on. And so I'm just going to be using a cutting board that I actually covered in saran wrap, cellophane wrap. Just because I don't have that tape, that cover. I'm sorry, a table to actually do it on. So I'm going to go ahead and carefully get some of the mixture, kind of mix it in a little bit. And I don't want to pour it. Or what's supposed to happen is supposed to create like a little wow when I put the ink on there. So let's see what happens. So we can see right here on my little cutting board, I got some of that, got some of the, what do you call it? Some of this. Okay. There we go. Try not to get all over my hands. Pour a little bit more. I'm assuming the more you put, the more the reaction will be. So let's go and see. Okay, cool. So now, oh, so sorry. Now I'm going to go ahead and, oh. So actually this is interesting because it didn't form the wow like we wanted it to. It's actually like holding on to the magnet. It went straight up to the magnet. And I don't know if it's a type of toner that I bought or purchased. And maybe that I put too much vegetable oil inside of it to make it too thin. So I'm gonna go ahead and put that down because it's gonna be dirty. I already got ink on me. Okay, so unfortunately that second part didn't work. It actually grabbed all the metals picked up and actually formed onto the the magnets, and I want to keep these magnets, so I'm trying to clean them off real quick. Ooh. So, yeah, no, it's not. So the metal just actually, instead of forming the welt, what it did was it actually went directly onto my magnet, and that just could be due to the fact that maybe I put too much toner on the too much vegetable oil inside the mixture, so that just liquefied it way too much. Let me just pick up this ink real quick. But what's supposed to take place is that the ferromagnetic particles within the magnetic field specifically align with the external magnetic fluid. So that's putting the rare earth magnet to the magnetic fluid, which was the the toner concoction we created earlier, and align with the external magnetic fluid, making a dome shape. So there's supposed to be a dome shape with or without spikes. And in this case, it did have the spikes, but the spikes came actually all the way up and actually hit my actual magnet, which is very interesting because you wouldn't think that the toner would have actual pieces of small particles like that. So that's interesting because that didn't happen in the video we watched. But what's supposed to happen is the spikes are a result of the strong magnetic lines in that particular direction and are present when nanoparticles are strong ferromagnetic particles and the external field is large enough. So the external field was our Earth magnets, and the liquid carrier fluid allows for shape changes to occur easily under various external magnetic fields. So that was my presentation. It's unfortunate that the second part didn't work out as good as the first part. A lot of mess to clean up. Hoping to not get it everywhere. Yeah, and so thank you so much for watching, Professor. I really appreciate your time, and it's almost the end of the semester. And these projects have been really fun. Some of them don't work out the way we want them to, but I definitely understand the concepts that come along with every lab that we're currently performing. So thank you so much for watching, and have a blessed day.